Well, good afternoon, everyone, and thanks so much for joining us today for Metalcon Live. I'm Judy Geller, Director of Metalcon, and I am here today with Kaylin Burke at the controls. Today, the Metalcon and the Metal Construction Association are happy to be bringing you thermal breaks in cladding support attachment assemblies. It's presented by Balil.
This is presented by Balil Khan of Northern Facades. I apologize for this little issue we're having currently. He is the architectural products consultant from Northern Facades. So a couple of things before we get started today. The next Metalcon Live is on March 2nd with the MBCEA's Keith Wentworth, VP at Dutton and Garfield, and he will be presenting temporary bracing guidelines. This session today is accredited by the AIA for architects. So for details on how to register and visit, look for our email, and we will be sending that later today so you can receive all of your credits. Today's presentation is brought to you by the MCA. Among their long list of benefits is a 10% off discount currently happening on exhibiting at Metalcon. Please contact Jeff Irwin for details. He will be happy to help you in any way possible. Also, the Metalcon 2022 call for presentations deadline is on Friday, February 18th. If you're an expert in a topic that would be of interest or would be of high educational value for contractors, subcontractors, architects, designers, or installers, and others in the metal construction industry, we invite you to apply. And of course, make sure that Metalcon is on your calendar for 2022, October 12th through the 14th at the Indiana Convention Center in Indianapolis. The Midwest is an important region for metal products, manufacturing, and metalworking technology, and we have not been there for a very long time. And is also an area for fun. Last week on a site visit, myself and the rest of our team toured the Indy 500 Speedway Museum and the NCAA headquarters and its museum. Both are amazing, whether you're an attendee touring the city or an exhibitor looking for an affordable and fun venue to host customers. Please contact Judy at metalcon.com for more information. Again, that's Judy at metalcon.com for more information. To get all the early info and news about Metalcon 2022, you can pre-register at metalcon.com. And last but surely not least, just a quick reminder, if you have any technical issues, you can reach out to Metalcon Live in the chat box, and I'll be the one to assist you. Again, today, to receive your AIA credits, please fill out the form immediately following this survey. We'll be sure to process those for you. All questions can be submitted either in the chat feature or in the Q&A feature on this screen right now. You can submit those at any point in time throughout this entire session, and we will review those at appropriate times. Thank you, everybody. I'm going to hand this right over to Bilal. Bilal, take it away.
Thank you, Kaylin. Thank you, Judy. And good afternoon, everybody. Thank you for joining me today and talking about thermal breaks and cladding support attachment assemblies. I'll just go over really quickly on some AIA best practices, as I'm obliged to, just before we get into the presentation. This program is registered with the AIA Continuing Education for Professional Education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, or distributing or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. Northern Facades is a registered provider with the American Institute of Architects Continuing Education Systems. Credit earned on completion of this program will be reported to CES records for AIA members. Net zero energy ready buildings are becoming a popular topic in today's climate changing world. Energy efficiency and high performing building envelopes drive a lot of design conversations, and generally construction is moving towards thermally broken subframing systems, which are rapidly becoming a new norm. This course will help participants understand how the use of thermal clips will impact thermal bridging on various exterior wall assembly applications, identify and compare various cladding attachment methods on the market, help participants learn how to determine the appropriate clip for your project, compare effective thermal resistance required to achieve project's targeted R value. My name is Bilal Khan, and I am an architectural product consultant at Northern Facades. But I really like to look at myself as a resource to architects, designers, and engineers with all things related to facades. Given my background, I really enjoy solving problems and getting into the details. You know, I hope you all have a great session through this presentation and find value in the things that we've learned throughout the years. So I want to start off the presentation with just creating a little bit of a context. 88% of energy sources are non-renewable and harmful for the climate. This is just a synopsis of where energy is currently being sourced in the United States. And as we all know, that if our energy is not renewable, it could cause adverse climate change effects that we're all experiencing, such as snowstorms in Texas, etc. Buildings that we live in require energy for all kinds of different things, and it could range from things like cooking and refrigeration, running motors and electrical devices, or even lighting. But the single biggest end use is space heating, which accounts for 42% of residential buildings and 36% for commercial buildings. Commercial buildings also spend $27 billion or 15% annually just to heat their buildings. And all of this sort of data is just to kind of create this sense of or understanding of how our energy is being sourced or produced, and how do we consume them. And given that, we would want to believe that building occupants would be pretty happy or pretty satisfied with the thermal comfort of their buildings, right? However, we stumbled upon a survey that says, no, that's actually not the case. Actually, thermal comfort is in a negative or dissatisfied zone. In a study conducted at UC Berkeley, we learned that a modern building performance is mediocre at best. And if you look closely at the sources of dissatisfaction with temperature, we will see opinions like, my area is hotter or colder than the other areas, or air movement is too low, or even heating and cooling systems do not respond quickly enough, which are all telltale signs of overall failure of the building to maintain temperature consistency, which leads us to believe that buildings are perhaps not performing at the level at which they were designed to, or if they were even designed to a standard, and that most commercial buildings are experiencing drastic heat loss. So before we understand how buildings lose heat, we need to kind of understand TEDI, or thermal energy demand intensity. TEDI is a measure of the amount of annual heating energy needed to maintain a building's stable interior temperature. And it takes into account heat loss through the envelope and passive gains such as warmth generated by sunlight, body heat, and appliances, etc. By targeting low TEDI, designers focus on passive solutions, or designers can focus on passive solutions like good insulation, air tightness, and beneficial sun angles that can help reduce energy used directly. Looking at these passive design aspects are always the first step in high performance design. To minimize heat loss from buildings, it is very important to design highly insulated design with highly insulated buildings, building assemblies, and have more exterior insulation or split insulation in wall cavities. But either of those two strategies fail if we fail to recognize the impact of thermal bridging across building envelope. So let's take a closer look at what thermal bridging entails. This is mostly a refresher, as I'm sure everyone present at this webinar knows what thermal bridging is, but just for context, a thermal bridge is an example of heat transfer through conduction, plain and simple. When there is a temperature difference, heat flow will follow the path of least resistance through the material with the highest thermal conductivity and lowest thermal resistance. This path is a thermal bridge. Thermal bridging is caused by highly conductive elements penetrating the thermal insulation or misaligned planes of thermal insulation. These paths allow heat flow to bypass the insulating layer and reduce the effectiveness of the insulation. Thermal bridges can occur through walls, roofs, and other insulated building envelope components through linear transmittance of floor slabs, through point transmittance of structural elements, and clear field assemblies, that is, transmittance which occurs due to the effect of uniformly distributed thermal bridging components like brick ties, structural framing, products like steel studs or studs in general, and cladding attachments. This presentation is going to focus exclusively on thermal bridges created through a clear field assembly. Thermal bridging is common to many forms of conventional construction. Prior to detailed studies of thermal bridging in building enclosures, assembly designers did not necessarily pay attention to heat flow by conduction through steel studs and reinforced concrete structures that did not benefit from continuous exterior insulation. One of the best ways by far to suck energy across the wall is a steel stud. Just look at the configuration. It's a highly conductive material that's designed for maximum absorption on one end and maximum emission on the other end. And it really doesn't get any better than this for heat loss or heat gain. Whether this assembly is insulated internally from a thermal perspective is irrelevant, as there are studies that were conducted that were where we see steel stud walls with no stud cavity insulation and a wall with cavity insulation. And when we compare them, you would not be able to tell the difference in thermal performance between the experimental area of measurement. Hence, the need for insulation on the exterior is the case, I guess, I should say, made for exterior insulation on the exterior is more has more legs to stand on than we think. Here's another look at the thermal bridge. Now you can see how the path of thermal transfer goes from the steel studs from the inside of the building via continuous Z-gird. And the only way efficiently and effectively to minimize this heat loss is through installing a continuous exterior insulation. As thermal bridges can occur throughout the building envelope, one strategy to combat them is continuous insulation. And this is not just your standard procedure of cutting insulation to tightly fit into the walls and taping them together through, though this is an important measure to ensure insulation's effectiveness, but continuous insulation is installed on the exterior side of the walls. So it isn't broken up by wall components, except for service openings and fasteners, as it's allowed for in the building code. In multi-story buildings, interior insulation can not be continuous. I mean, that's something that we've learned over the years through perhaps many experimentation. However, in order to meet the building code standards that require continuous insulation, as many codes now do, the insulation must be installed over wood studs and before sheathing. Exposed slabs can act as thermal bridges that can increase a building's U value by 1%, especially when repeating continuous insulation is the best strategy to combat this. So let's break down the concept of continuous insulation. Insulation is measured in R values or resistive values. A section of this insulation is, or a section of any insulation is roughly 3.1 R per inch. And this is a nominal value, meaning it's R value and without it being installed in a wall assembly. But what designers need to consider is the effective value, which considers the R value of the insulation after it is installed in the wall assembly and accounts for penetrations and other thermal bridging components that are penetrating it. So let's take an example. Let's take an example of 6-inch batt insulation, which is rated R19 nominally, roughly 3.1 per inch. However, as soon as we add steel studs through this, its performance diminishes to as low as R7.1, which we call the effective R value, meaning that when meaning that with steel studs, designers would have to add around 3 times more insulation to bring it up to its R19 value, which poses some serious design challenges and within the stud cavity, as you can imagine. So we resolve this exterior insulation where as soon as we add continuous insulation on the outboard of sheathing, we can get an effective R value of roughly 23 or even more, depending on how much exterior insulation we want to layer up. And we can get a higher performance wall, provided that it is thermally broken through a cladding attachment strategy. Here's an excellent representation of insulation in the stud cavity. The wall on the left side shows absolutely no resistance to the heat flowing to the outside of the building, whereas the wall assembly is definitely better performing on the right-hand side. And you can clearly see that it's a much better performing wall. So addressing thermal bridging is important during the design detailing stage because it can result in increased energy required to heat or cool the buildings to accommodate for winter heat loss and summer heat gain. As we all know, that energy conservation is a hot topic as building codes are increasingly becoming performance oriented. So let's just kind of take a little bit of a stroll into the building codes and see why is it so important for us to perhaps consider thermal bridging in exterior building envelopes. So in USA, there are 2 predominant building codes, the IECC 2021 and ASHRAE 90.1. There are different versions and adaptations of these codes and standards in effect across different states and cities in USA. However, all require consideration for thermal bridging and effectiveness of insulation, or at least are moving in that direction. And then on top of that, there are green building codes such as ASHRAE 189.1, IGCC, and the voluntary programs like Passive House, LEED, raise the bar even further for high performance building envelopes. And one thing to note is that wall effectiveness, R value, and U value are an integral part of energy code compliance. Outboard continuous insulation presents an efficient and cost-effective method to meet thermal performance set out in these standards. However, the effectiveness of this approach hinges on the selection of a thermally efficient cladding attachment strategy and detailing, which we will get to in a minute. Another thing to note is that cladding attachments can be significant thermal bridge if they are not thermally broken, and can reduce the exterior insulation performance as little as 5 to 10% in high performance systems, mechanical or otherwise, and as much as 80% for poor systems that are in need for major retrofit. With the updated code, all buildings' energy efficiency, both commercial and residential, is estimated to rise about 10%. And high standards for increased continuous insulation requirements will help commercial buildings become more energy efficient. In the 2021 commercial code, commercial buildings are required to display an energy efficient certificate that lists R values of the insulation. And numerous updates have also been made to better align ASHRAE 90.1 to the current code. And these changes include updates to roofing assembly performance and above grade wall assembly performance through continuous insulation. So just a quick synopsis of what the changes kind of look like. Overall, there's an average 49% increase in effective R value for above grade wall assembly, which specifically calls out continuous insulation. And there is stress on exterior insulation versus cavity insulation. And with the way the insulation, with the way the R value or the performance criteria has increased via IECC 2021, it's very difficult to just achieve R values or just achieve performance criteria within stud cavity insulation alone. And if it has to be exterior insulation, it needs to be with a proper cladding attachment strategy. There is no doubt about that. The status of energy code adoption in commercial buildings is very rapid from the standpoint that we are looking at it. And there are many states that have already moved on to the ASHRAE 90.1 code, the 2016, which is the latest version. And most states are slowly and gradually moving towards that standard as well. And as required for energy efficiency to become more demanding, the primary role of the enclosure is becoming recognized as the most cost-effective means of attaining high-performance targets. The table here indicates recommended effective R values for various enclosure components for use. Various components used in residential buildings. These are effective R values that account for thermal bridging effects. The table here indicates recommended effective R values for various enclosure components for those used in steel stud, commercial construction. These are, again, effective R values that account for thermal bridging effects. The challenge designers and contractors face is in selecting and evaluating an appropriate cladding attachment strategy for their project, and understanding the implications these decisions have on effective thermal performance, installation methods, sequencing, and system cost. These are just a sampling of the different products that are out there. So as you can imagine, there are several different products, all having their own pros and cons, their own acceptable standards, and the way they're probably better or worse in a given situation. But what's really consistent across the board is that all these systems work on the principle of enabling a thermal bridged subframing system that enables continuous insulation. The nuances of each system vary by detailing, installation techniques, and system cost, which we'll get into in a little bit. typically the thermal bridging is buried within the insulation layers, and which stops from heat flow to pass on to the subframing, and it prevents any cool air from transferring into the building. And as I mentioned, there are so many different clip and rail systems on the market. Which ones should architects focus on, or what's the criteria to even start to evaluate them? So I want to start with the point that there is really, all clip systems aren't the same. They all have different nuances. And how do you pick, or how do you start selecting them? Well, there are independent analysis, such as this one that I'll go through by independent engineering company, RDH, that evaluates, and there are many others that are out there, that evaluate system performance and design performance of many of these clips. It looks at structural strength, and it looks at the thermal performance. And different materials and different combinations of materials all have a play on the performance of the building. And it's really up to the designer, and it's really up to the project standards to determine which clip would be most appropriate for detailing the type of cladding attachment system that the designers want at the end of the day. The analysis that RDH came up with, that from a starting point, having a thermal bridging strategy in place is a good thing. But within that, there are good, better, and best solutions that are out there. So although you'll notice that there are various systems and performance are quite relative in terms in the best category, it is not a full picture, as performance analysis does not consider constructability and relative cost. So on the right side of the screen, you'll notice that there's a relative cost of the system, which is just to procure the products. There is a performance standard, which the project has to meet. And then there's constructability of how easy it is for construction crews to install the system, and whether or not it is compatible with the project timelines. Is it a fast-paced project where there are prefabricated wall panels and they really need the building facade up in 3 months? Or it is a custom residential project or a custom project that requires very extensive and elaborate cladding system, or a versatile cladding system that's adjustable. So that those are all dependent on the project specific criteria. The table here shows the percentage effectiveness of exterior insulation with various cladding support systems, and the typical thickness of exterior insulation, roughly from 2 inches to 8 inches, that goes from R8 to R40 in R value. It is apparent that traditional techniques such as Z-girts can at best achieve about 50% of exterior insulation effectiveness, essentially requiring us to double the thickness of exterior insulation to achieve an effective thermal resistance that approaches the nominal value. High performance buildings require high performance enclosures that manage heat flow effectively. The proper selection, arrangement, detailing, and integration of the enclosure components and assemblies to maintain the continuity of thermal insulation and the air barrier system are no longer best practice, but a standard practice, and needed to be complied with the codes and the standards. So I'm not saying that it's a big deal, but it is a pretty big deal. So just looking at some high performance buildings here, and just kind of looking at it from a hydrothermal perspective through thermal imaging. And you can see that in this image, before the building's leaking severe excessive amounts of heat, and you can see that the entire building envelope is just completely lit up. Whereas after a retrofit of the exact same building, you will notice that heat is not finding a lot of opportunities to escape through the building facade, which is quite interesting and a very real analysis of what high performance buildings look like and what continuous insulation can do for making that building high performing. In another example, this is kind of a colder area, and you can see the mountains with snow in the background. And you can really see how effective exterior insulation is in this case, where it's really limiting the flow of heat. You can only see it on the corners and some glazing, some window areas where it's probably penetrating from. And even that warrants further investigation, whether or not that is a component inside that's showing that or not. But if you look at the buildings on the further left or the further right, you'll see that those are not high performing and therefore are leaking excessive amounts of heat. Thermal insulation and while the control of moisture is practically a universal requirement for buildings, the importance of control of heat transfer tends to become more critical as the severity of climate, either hot or cold, increases. And managing heat flow is critical to occupant thermal comfort, energy efficiency, durability, and increasingly thermal resilience during periods of extended power outages as we continue to experience as climate change sort of takes effect. The primary impact of a thermal bridge is that it will allow conditioned air to leave the building and losing heat in cold weather and gaining heat in hot weather. This may have a significant impact on the comfort of the occupants, not just the overall temperature that they experience, but also when they touch the colder or hotter than average walls and floors. If your building must maintain a certain temperature, whether it's room temperature for people or a specific temperature for stored goods, a thermal bridge can make it more expensive to maintain that temperature. Thermal bridges allow for warm air to mingle with the colder air. They frequently encourage condensation. This effect is more pronounced in areas with high humidity than in areas with relatively low humidity. When condensation occurs in a building, it has many effects on air quality. It could allow for mold to grow and negatively impact the health of building occupants, especially those with breathing problems. Constant dampness may cause damage to drywalls and furniture and other items. And probably the biggest and most expensive gremlin of all is interstitial condensation. From a thermal bridge standpoint, it may not necessarily end up in the exterior of the building. Instead, it may just collect in between the walls and other building elements. And it has some serious impacts on longevity of a building in question. Wherever moisture collects, rot and rust may follow. So if you cannot see the condensation because it is in the walls or pipes, you may not be able to fix it in time or address it in time, and it would have caused severe damage to the building structure. In climates with cold season, it is advisable to place all of the insulation on the exterior of the air leakage control plane to manage the risk of condensation due to air leakage. However, this makes energy efficient walls very thick. And an alternative approach is to combine interior and exterior insulation in proper proportions to manage moisture. There are several considerations which must be made in order to or in choosing the type of exterior insulation and cladding attachment strategy for a building. These typically include at a minimum different loads, either dead load, wind load, or pull-out resistance, backup wall construction, whether it's wood, concrete, or concrete blocks, steel stud framing, structural attachment point, whether it's through studs or sheathing or slab edge, outboard insulation thickness, and types of insulation. But in addition to these requirements, there are performance requirements that come with all these new standards and codes, or ever evolving standards and codes, which ask questions such as what is the effective R value target and tolerable thermal efficiency loss from supports? What is the orientation of the subframing system? Either it's vertical, horizontal, and what are the required attachment points? It is super important to consider details for attachments of cladding at corners, transitions, returns, and penetrations, and combustibility requirements. Oops. There are three major structural forces when considering with facades or considering cladding attachment strategy, thermally broken cladding attachment strategy. Those are wind load, dead load, and pull-out resistance. Wind load and dead load impact the spacing of the system. Pull-out resistance is a measure of the fasteners and the type of fasteners used to fasten the subframing system to the wall. Spacing of the attachments has many different implications, and each product has a different load charts. Each manufacturer has different load charts that designers and installers can rely on, and these variables are either broken down by wind load, weight of the cladding system, the type of girt assembly that's required, substrate upon which the system is being fastened on, and the depth of the insulation. However, the project engineer on record must verify the clip spacing based off of the manufacturer's recommendation and sign off before anything can be done. This is just an example of a typical load chart and type of data that you can find with manufacturers. And depending on the thermal attachment, there are many different girt and fastener approaches. And some thermal attachments use one type and adjust the girt size to accommodate different insulation thicknesses, while others have different size attachments for different insulation thicknesses. Some products are adjustable that require no shims, and while others require for different kinds of attachments to accommodate for horizontal or even vertical insulation. So there's many different flavors. Like I said, no two thermal clips or thermal bridging, thermal clips or thermal attachment systems are the same. It's important to understand, because we're talking about thermal bridging and we are talking about the performance of a exterior wall or exterior wall assembly. The more thermal clips or cladding attachments that are on a exterior wall, the less performing the wall will be, even though it is going to be a thermally broken system. But with more penetrations, you'll have more opportunities for thermal bridging. So it's also important to understand that the system that an engineer or a designer is going with is designed or engineered for high load, high capacity that can handle high or maximum wind loads and dead loads, and can also be spaced a lot further than other systems to optimize the exterior wall performance. Fire propagation is a very hot topic, no pun intended, in the last several years, and many components and many wall assemblies have gone through various forms of testing to sort of rule out any combustibility in components or any fire propagation elements and components that are part of different products. Because at the end of the day, there are human lives that are associated in buildings that live in these buildings. And of course, this is an image from the Grenfell Tower in the UK. And many souls perished on that day when this building caught on fire. And it kind of, again, reminds us how important it is to really keep in mind safety of users and occupants. So the most important test for determining fire propagation is NFPA 285 in the US. The thing to note about NFPA 285 that it is not a component test. It is a test of an entire wall assembly and a component. So a thermal clip or a cladding attachment will be a component in the overall wall assembly. And that wall assembly is mounted on a testing rig, which kind of looks like something like you see in this diagram. The way the test is performed is that a pilot flame is lit on the inside, as you can see in the window, and it kind of increases in intensity. Eventually, this little opening creates the scenario of fire leapfrogging onto the exterior of the building, and the building is then, it keeps burning. This raging inferno keeps on going for roughly 30 to 40 minutes. And what they are trying to assess through this exercise is determine the extent of the range of the fire, the height of the fire, and how how the combustible components, if they are part of the building assembly, whether or not they're aiding to that to that flame or not. The image on the right-hand side is actually an image of a test that was a wall assembly that passed in an FBA 285 test, as devastating as it looks. But they really want to gauge through the markings that they have on the left and the right-hand side of how high the flame travels in that 30 to 40 minute window. So we did talk about details, and I'll go over some details real quick of how product manufacturers can assist and provide value in the design process and are integral to the design process, in fact. And some things that they should typically have are details that are part of their resource books or resource manuals, and you'll find many different details in this presentation that basically talks about different joints, either horizontal or vertical, window head, window sill, window jambs. And again, the whole idea is for a thermally broken system, at the end of the day, yes, it's creating a high performance wall, but it is creating the subsurface for the cladding product to be installed on. And if that product is not installed correctly, it can ultimately be traced back to the system upon which it's being installed on. And parapet details and termination details. So there are all these different details that can help designers figure out the best course of action for all the different intricacies of a project. So to do a little bit of a recap before I can move into talking a little bit about a specific product, is that energy conservation should be our collective goal. Building codes are challenging designers and builders to adopt high performance methods and products. Energy conservation can be achieved by designing buildings that use less energy. And the best way that we know today as designers is to design with thermally broken cladding attachment systems and continuous insulation. We can get into some questions right now, or I can perhaps finish the last couple of slides that I have. Kayla, what do you recommend?
Yeah, so actually I do have one question for you, and that is coming from an individual named Jeb. And Jeb is asking, is this with or without sheathing?
The most cladding systems that are on the market, they're installed after the sheathing, but they're installed to the structural member. Now that structural member could be the steel stud or it could be the wood stud, but it's installed after the sheathing.
Okay, perfect. We don't have any other questions quite right now. But yep, we're going to have some more, I'm sure, in the next few minutes. So feel free to continue.
Okay, awesome. So I just like to take the next few moments here to talk about the IsoClip, which is a product by Northern Facades. IsoClip is a thermally broken structural attachment for cladding systems to the exterior wall assembly that significantly reduces thermal bridging within exterior rain screen assemblies and help achieve continuous insulation, resulting in improving insulation effective R values and building envelope performance in general. Isoclips are available in 3 sizes to accommodate for insulation thicknesses. Isoclip is manufactured from 14 gauge galvalume or galvanized steel with an integrated glass fiber reinforced polyamide isolator pad. Isoclips is an integral product that improves building energy efficiency through a reduction in thermal bridging, utilizing an optimized thermal pad design. Isoclip is designed for high load capacity. Less isoclips may be required compared to synthetic or aluminum clips, which means less isoclips to install and less thermal bridging. Isoclip is simple and easy to install and is preferred by contractors and installers for achieving efficiencies during construction, resulting in cost savings. Perhaps the best advantage of Isoclip is its adjustability. It is adjustable for up to plus or minus half an inch, which is quite significant on an exterior wall. In both directions, either horizontally or vertically, without the need for shims. And it helps achieve continuous insulation, which, as we have probably internalized through this presentation, is the most necessary thing to achieve building codes or meet building codes. Isoclip's built-in helping hand is designed for ease and speed of installation. And it's incredibly important considering how crucial it is to meet construction deadlines. Isoclip is always installed in the same direction, regardless of horizontal or vertical girth orientation, and it's North American made. Isoclip has extensive performance data and meets extensive performance requirements and has been validated by external engineering consultants for structural and thermal performance. And it has been evaluated for NFPA 285 and has been utilized in a successful NFPA 285 test. It is fully engineered and acceptable for multiple substrates. Northern Facades is committed to sustainability and ensuring that our products not only meet and exceed specification requirements and have minimum possible impact to the environment and the carbon footprint. As a component part, Isoclip may assist towards several lead credit points. Isoclip can be specified for salmon safe projects. Salmon safe is a standard that is developed in the Pacific Northwest to protect salmon habitats from the disruption of construction activity. In this case, it means any zinc runoff can be detrimental to salmon habitats. So to safeguard against that, our team developed a nylon-coated clip. This allows Isoclip to protect downstream water quality and is consistent for use in salmon-safe projects. Isoclip is also registered on the Living Futures Institute of Sustainable Products, which has provided Isoclip with a declare label, recognizing that Isoclip is free from any red-listed chemicals and components, and upon the end of its life, is fully salvageable or reusable in its entirety, and it's 100% recyclable. Northern Facades has also developed an online tool called the Isoclip Calculator, which is an online tool that can help designers during preliminary design stages determine the wall performance by simply tweaking their wall assembly and by selecting different combinations of clips and wall types to achieve the required performance within the cladding, within the wall assembly, and for the type of cladding system and the wind load criteria for that specific project. So it's a pretty comprehensive, pretty robust tool. And of course, if there are applications that you find yourself in, or situations you find yourself in that the calculator, which exceed the parameter of the calculator, the Isoclip team is more than happy to help. Isoclip has very extensive technical support. A lot of our product information can be found on isoclips.com. Of course, Isoclip structural calculator is something that I just touched base on, but a lot of our technical information is found in the box link. Feel free to reach out and I'll be more than happy to share that. All technical questions can be referred to info@isoclips.com, and Isoclips is also listed and can be found on leading specification platforms. And that is all from my end. I would like to thank everyone again for attending this presentation today, and I hope it was a good learning experience for everyone, and it was valuable information.
I'm 100% certain that is exactly the case below. I do have some questions that have come through. Are you open to answering a few?
Absolutely.
Fantastic. So I have one person saying that I noticed on one of the details what appeared to be a washer that wasn't metallic, apparently further breaking the thermal bridge. But to what extent do the screws, presumably metal screws, generally contribute to thermal bridging?
It's a very good question. And so one way to look at it is that the way ASHRAE 90.1 describes thermal bridging or continuity or breaks in continuity is, or the exceptions that they create are either through fasteners or through mechanical penetrations. In the case of Isoclip, if I may just go back a few slides, or maybe this is the probably good one. If you notice that the fasteners do continue from outside and connect the studs, connect to the studs, the overall clip is buried within the insulation. So the reason why Isoclip will perform to the standards that it is designed to is if it is embedded within the layers of insulation. That gives it not just Isoclip, but in fact any other product, if it's not buried within the insulation, it probably will not perform as required. And the thermal washers would provide minimal benefit if they are part of a particular product.
Okay, very interesting. So I have another question. What country is the ISO clip manufactured in? And what fasteners are shown with the ISO clip?
For sure, yeah. So ISO is currently manufactured in Canada, but it's shipped all over North America from Canada. The fasteners, we have a list of fasteners that are recommended, and of course project engineers could swap them out, but the ones that you see are 1/4 inch number 14 fasteners. These are the ones for the steel studs, and there could be different ones for concrete or wood studs. I think the ones for steel studs and wood studs are the same.
Awesome.
Tapcons for concrete, excuse me. They're Tapcons for concrete.
Tapcons, okay, perfect. How do you deal with condensation in these walls?
So the way condensation sort of finds its way into the wall is when the dew point within the dew point is outside, or not within the stud cavity. And in most of the buildings that are a little bit older, you'll find condensation around windows. And there was this one hospital that I went to where they had a baseboard heating system and a window right above it. And because there was no exterior insulation and it was so frigidly cold outside, the heater was definitely trying to keep the space warm. A baseboard heater was trying to keep the space warm. But because of all the air leakage and the dew point moving inside of the wall cavity, the window was completely drenched and soaked in condensation. So exterior insulation, what it does is it enables that dew point to fall within the layers of insulation, because that's really where you want it to be. If it's not in between those layers, then there's going to be condensation or interstitial condensation for sure. Dew point analysis, there are many different tools that are there to determine that. A lot of building envelope consultants offer dew point analysis on assemblies that are designed by architects. So there are many tools that are out there and many resources to glean from to eliminate any kind of risk of condensation when detailing.
Fantastic. And I think this might be our last question.
Mhm.
So this is coming from Brant, and he is asking, from the 2018 RTH study that you quoted, do you have any updates? And further, why would designers choose something other than long screws through insulation based on that data?
That is an excellent question. I'm so glad you were paying attention, Brent. You're right in terms of thermal performance. Yes, long screws for sure are a total. They're totally leading, but long screws have limitations when they deal with the type of cladding product that's being attached. So, for example, in the detail that I have on the screen right now, there's like an MCM panel with a clip or a rail system. It's very difficult to achieve that with long screws. But if you're detailing some sort of siding or any kind of siding, long screws is the way to go. We would probably not even advise using isoclip for that kind of application. So there are different nuances. There are many different variables, I would say. And same goes for other systems like mechanically fastened brick or masonry products, or any kind of products that use rails or clips. You need to have girts in place, and you need to have or some sort of subframing in place. And long screws don't necessarily or aren't necessarily designed for that application.
Okay. Well, I think those are all the questions. If anyone has any questions while I'm giving the final outro, please feel free to leave them in there and I'll try and sneak them in immediately following. But thank you so much, Bilal. We so appreciate your time, and thank you everybody else for joining us today. Again, we 100% appreciate you joining us. You will be, anyone who needs that AIA credit, it will be immediately processed. You should see that within 1 to 2 weeks. If you have any questions about this topic, please feel free to reach out to either Metalcon, or you can reach out to Bilal as well. We are both happy to answer questions that you may have. If you need any other credits, you will be receiving that certificate, and that certificate will have all the information that you need to maintain your crediting for any other organizations. We hope you'll join us in 2 weeks on March 2nd with Keith Wentworth and the MBCEA. Thank you again, everybody, for joining us. Have a great rest of your day, and a very special thank you to Bilal. Bye, everyone.
Thank you, Kayla. Thank you, everybody.